Welcome back. Oh, yes, you're here. I am so glad to see you again. I've been stuck inside the game since our last lesson, so I've been exploring this alien planet and I found a lot of cool stuff. But most importantly, I found a way out. Here comes my ticket out right now. This is Exponent. He lives here on planet Algebra. We worked out a deal, and he says that if we can solve 3 riddles, he'll take me back home. To solve the riddles, we'll need to use the exponent properties to analyze and simplify expressions. You should still have access to the property inventory tool. Is the inventory icon still in the bottom left corner? Awesome. And make sure you have your property inventory sheet handy as well. Are you ready to put your powers to the test and help me get home? Exponent, we're ready.
Three paths lay before you, but which goes the right way? The first step of simplification is different for path B and path A. Are both free of error, without a mistake? If so, then choose path C to decide your fate.
3 paths, and we need to choose the correct one. The riddle said the first step of simplification is different for path B and path A. The original expression is the one at the middle, at the top of the screen, and then the expressions on path A and B are just the first step to simplifying the original. We need to figure out which path shows the correct first step. But then there's also path C. The riddle says, are both free of error without a mistake? If so, then choose path C to decide your fate. So I guess there's also a chance that both first steps are correct? Do you think that's possible? Let's take a closer look. Take a moment here to pause the video and analyze both options. Try to identify which property was used for each path. In the original expression, I noticed that the variable in the numerator has a negative exponent. And in the denominator, there's a chunk of the expression within parentheses raised to the power of -2. Starting with path A, I noticed the parentheses and outer exponent in the denominator are no longer there. Which property do you think was used? Well, there was a product inside the parentheses, so maybe the power of a product property? How can we check to be sure? Yeah, let's use the power of a product property to simplify the denominator of the original expression and see what we get. Pause here to do that now. According to the power of a product property, the outer exponent can be distributed to each element within the parentheses. Then the exponents with the G and H elements can be multiplied. This matches path A, but just because it matches doesn't necessarily mean that it was the correct first step. Let's make sure path A followed the order of operations. Starting with groupings in the original expression, is there anything within the parentheses that needs to be simplified? Everything within the parentheses is simplified. The next step of GEMS is exponents, which means we're looking for anything requiring the 0 exponent property or any of the power of properties. And hey, the power of a product property was the first step that was done in path A, so path A is correct. But remember, there's also the option of path C, that both A and B are correct. So what about the expression in path B? In the original, the G component in the numerator had a negative exponent, and so did the grouping in the denominator. In path B's first step, it appears that the numerator and denominator swapped places, and those 2 negative exponents are now positive. Were you able to identify which property was used there? That must be the negative exponent property, which states that a component with a negative exponent can be rewritten as its reciprocal with a positive exponent. But I noticed that there's still a negative exponent here inside the parentheses. Should this exponent have changed to be a positive too? Well, for this chunk of the expression, -2 is the exponent, which means everything inside the parentheses is the base. The negative exponent property tells us that the component can be rewritten as its reciprocal, which is this whole chunk. And then its exponent becomes positive, which applies to just this -2, so nothing within the base should change. We determined that path B used the negative exponent property correctly. But was it supposed to be used as the first step in simplifying the original expression? Remember, the negative exponent property can be used at different times depending on what you prefer. In path B, it was used as the first step, which is perfectly okay. So does this mean both path A and path B are correct? There's only one way to be totally sure. If both paths are correct, then the final answer should be the same for both. Pause here to finish simplifying both of these expressions. Take your time, follow the order of operations, and if you get stuck, use your property inventory sheet as a reference. So, do they match? Here's path A, and here's path B. They do, because both options use the properties correctly, follow the order of operations, and give us the same simplified answer. They are both correct. Okay, Exponox, we know which path to choose. We choose path C. We did it! Okay, Exponox, what's the next riddle?
The expression at hand is simplified but askew. The result is a miss. Spot the error that slipped through.
Spot the error that slipped through. So on the left is the original expression, and on the right is the answer, but it's incorrect. And we need to determine what mistake was made. Is that right, Exponox? Do you have any idea what the mistake was? I think I know, but to be on the safe side, we should simplify the expression ourselves and then compare our answer to the incorrect one. Pause here to simplify the original expression in your guided notes. To take care of the grouping in gems, we need to simplify everything inside the parentheses before addressing this outer exponent of 4. The quotient of powers property tells us that when elements with the same base are dividing, we can subtract the exponents. For the x's, the exponent in the numerator is larger, so these can be simplified to x to the power of 6 minus 1, or x to the 5th. For the y's, the exponent in the denominator is larger, giving us y to the power of 2 minus 1, which simplifies to plain old y. Now that the g step of gems is complete, let's move on to the e step and deal with the outer exponent. This division inside the parentheses is raised to a power, so we need the power of a quotient property, which tells us that the outer exponent can be distributed to the numerator and denominator. Which property should we use to simplify the numerator now? This is a product raised to a power, so we need the power of a product property, which tells us to distribute the outer exponent to each element within. 2 to the 4th becomes 16. X to the 5th raised to the power of 4 becomes x to the power of 5 times 4, or x to the power of 20. And in the denominator, y to the 4th is already simplified. How does our simplified answer compare to the incorrect answer Exponox gave us? Our answer has 16, while Exponox's answer has 8. We found the difference, but we need to determine what mistake was made to answer the riddle. So what do you think the mistake was? to get 16, we distributed the outer exponent of 4 to the 2, which gave us 2 to the power of 4, or 16. What do you think Exponent did with the 2 and 4 instead? He must have multiplied them. I see how that mistake could be made. When we distribute the outer exponent to a component with another exponent, like x to the 5th, the exponents multiply. But the 2 didn't have an exponent. So when the outer 4 was distributed, that made this component 2 to the power of 1 times 4, or just 2 to the power of 4. So Exponent's mistake was that he multiplied the constant by the exponent instead of raising the constant to the power of the exponent. We figured it out. We are ready to tell you the mistake. When the power of a product was used to distribute the outer exponent, the 2 and 4 were multiplied instead of raising the 2 to the power of 4. So the 8 should actually be 16.
Simplify the expression with greatest precision, for it unlocks the portal of your earthly mission. This is your final chance to escape the unknown. Solve it correctly to find your way home.
This riddle seems pretty straightforward. Simplify the expression as much as possible. Pause here to do that now in your guided notes. Starting with the groupings, the numerator and denominator groupings need to be simplified first. In the numerator, the zero exponent property tells us the b to the power of 0 equals 1. In the denominator, we can simplify the a component with the power of a power property, giving us a to the 6th. From here, I would use the negative exponent property to move the a component in the numerator down to the denominator, making its exponent positive. Then, according to the product of powers property, I could combine the a components by adding their exponents. In the numerator, 8 times 1 is just 8. And finally, 8 divided by 8 is 1. So these 8s cancel each other out, leaving us with our final answer. All right, Exponents, I hope you're ready to take me home because we're about to crack your third riddle. The simplified answer is c to the 4th over a to the 8th. Hey, where are you going? Ah! Ah! Oh, I'm home. Wow, what a game. We learned all of the properties of exponents, how to use all the properties to simplify expressions with exponents, and we even got to hang out with an alien on planet Algebra. All that's left is to complete the online practice and, if you're feeling up to it, the error analysis bonus activity. And you know what? I think we can finally say we did it. We harnessed the power of the power! See you next time.